Hello everyone. Today we will going to see some practice questions from the chapter solution and it is part 6. So let's start. First disclaimer slide which says the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. Moving on to the index slide. So we will going to see some practice questions from question number 9 to 15. Let's start with question number 9. The vapor pressure of benzene at a certain temperature is 640 mm of Hg. A non-volatile, non-electrolyte solute weighing 2.175 gram is added to 39 gram of benzene. The vapor pressure of the solution is 600 mm of Hg. What is the molecular weight of solid substance? So options are 6.96, 65.2, 63.8 or none of the above. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option B. So we know that the lowering in vapor pressure is equals to the mole fraction of solute. So on putting the values given in the question, we have P naught is equals to 640, P1 is 600 divided by P naught, which is 640, is equals to given mass of solute 2.175 divided by the molar mass upon given mass of solute plus, number of moles of solute plus number of moles of solvent. And on interchanging the terms, we have 0.0625 into 2.175 divided by M2 plus 0.5 is equals to 2.175 divided by M2. And on equating and solving these terms, we have M2 is equals to 65.2. So the molecular weight of the solid substance is coming out as 65.2. Hence, our correct option is option B. Okay, let's move to question number 10. The vapor pressure of a solvent decreases by 10 mm of mercury when a non-volatile solute was added to the solvent. The mole fraction of solute in the solution is 0.2. What should be the mole fraction of the solvent if the decrease in vapor pressure is to be 20 mm of mercury? Options are 0.8, 0.6, 0.4 or 0.7. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option B. So we know that del P upon P naught, or you can say del P is equals to mole fraction times the P naught. Del P is 10 mm of Hg, as we can see in the question. That the pressure of solvent decreases by 10 mm of mercury or Hg. So we have del P is 10 divided by P naught equals to mole fraction, given which is given in the question as 0.2 for the solute. So it is equals to 0.2. And on equating the terms from left to right, we have P naught equals to 50 mm of Hg. Similarly, 20 divided by 50, because it is given that if the decrease in vapor pressure is to be 20, so next decrease is 20, so del P is 20 divided by the 50, because this is not going to change. P naught is 50 is equals to mole fraction, and mole fraction we have to find out. So from this we have X2 equals to 0.4 for the solute when the change in the vapor pressure will be decreased by 20 mm of Hg pressure. So mole fraction of solvent will be 1 minus the mole fraction of solute 0.4. So 1 minus 0.4 is 0.6. So mole fraction of solvent is coming out as 0.6, and hence our option B is the correct answer. Okay, let's move to question number 11. At 310 Kelvin, the vapor pressure of an ideal solution containing 2 moles of A and 3 moles of B is 550 mm of Hg. At the same pressure, if 1 mole of B is added to the solution, the vapor pressure of solution increased by 10 mm of Hg. What is the vapor pressure of A in its pure state? So we have to find the vapor pressure of A in the pure state, and we have given that we have 2 moles of A and 3 moles of B initially at the vapor pressure of 550, and at the same pressure then we have 1 mole of B added to the solution, so it will become 3 plus 1 4, and then the vapor pressure which is increased of the solution is by 10. So we have to find out the vapor pressure of A in its in the pure state. So options are 460 mm of Hg, 610 mm of Hg, 360 mm of Hg, or 750 mm of Hg. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer will be A option. So we know that according to Dalton's law, P or total pressure is equals to the sum of multiple of the vapor pressures of pure solvent and solute multiplied by their mole fraction. On writing the values given in the question, we have total vapor pressure as 550 is equals to PA naught into the mole fraction for A, that is solute, which is 2 by 5 number of moles of solute upon number of moles of solution, plus PB naught 3 by 5 number of moles of solvent upon the total number of moles in the solution. And on solving this equation, we have 2 PA naught plus 3 PB naught is equals to 2750. So when 1 mole of B is added to it, right, it is given the question that finally we add 1 mole of B in the solution. So when 1 mole of B is added to the solution, the pressure will change to increase by 10 mm of Hg. So 550 will become 560. So 560 is equals to PA naught 2 by 6 plus PB naught 4 by 6, because the moles of solution will change and moles of solvent will change. And on solving this, we have 2 PA naught plus 4 PB naught is equals to 3360. This is our second equation, and this is our first equation basically. Right, so from equation first and second, we get on solving these two equations, we have PA naught is equals to 460 mm. Okay, so this is what we have to find out, right? That the vapor pressure of A in its pure state. So the vapor pressure of A in its pure state is coming out as 460 mm of Hg. Thus, the option A is the correct answer. Okay, let's move to question number 12. Which one of the following statements is false? So we have to find out the false statement. Options are: Raoult's law states that the vapor pressure of a component over a solution is proportional to its mole fraction. The osmotic pressure pi of a solution is given by the equation pi equals to mRT, where m is molarity of the solution. The correct order of osmotic pressure for 0.01 molar aqueous solution of each compound is greatest in BaCl2, then KCl, then CH3COH, and then least in sucrose. Or two sucrose solutions of same molality prepared in different solvents will have the same freezing point depression. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option D. In the A option, we have given that the pressure of A is equals to mole fraction and vapor pressure of A in pure form. This is true. So the statement is true. In the B statement, we have pi equals to MRT. So pi is generally equals to I MRT. So when Ventov factor is equals to I, it will become MRT. So this option is also true. Or this statement is also a true statement. Then C option is that pi is directly proportional to I, or Ventov factor, greater. Greater the value of I, larger the value of pi. I for BaCl2, which is a strong electrolyte, is 3 because BaCl2 on dissociating gave Ba2 positive plus 2Cl negative. So 3 ions it will give. And I for KCl is I for KCl is 2 because KCl on dissociation gave K positive and Cl negative, so 2 ions. I for CH3COH is less than 2 because CH3COH dissociates into CH3CO minus plus H positive, so 2 ions. So it will be less than 2, so it will be counted as less than 2. But CH3COH is weak electrolyte than KCl. You can compare the KCl and CH3COH. So CH3COH is a weak electrolyte. I for sucrose is 1 as it is a known electrolyte. So if we see the ratio, or if we see the order for the I of BaCl2, KCl and CH3COH and sucrose, so this will be the order, and it is same to thing given in the option C. So thus option C is also true, but we have to find out the false option. Now D, according to the D option, we have del TF or depression and freezing point is given by Kf into molality. Kf is dependent on the solvent, right? And we have given that we have two different solvents. So the Kf will also be different. Thus, the freezing point and molality is same for both the solvent, right? So the freezing point will be equal to del Tf of solvent 1 and del Tf of solvent 2. Difference of these two, and they both are different. So del Tf will also be different for the two solutions. Thus, the D option is false because in the D options we have given that the depression freezing point is same, but they are different. So thus, D option is false. Hence, the correct answer is D option because we have to find the false statement, right? Okay, move on to question number 13. Two beakers of capacity 500 ml were taken. One of these beakers, labeled as A, was filled with 400 ml water, whereas the beaker labeled B was filled with 400 ml of 2 molar solution of NaCl. At the same temperature, both the beakers were placed in closed containers of same material and same capacity as shown in the figure. At a given temperature, which of the following statement is correct about the vapor pressure of pure water and that of NaCl solution? So we have two beakers. In one beaker we have water, in one beaker we have NaCl solutions. So we have to find out which statement is correct on the basis of these two beakers, or on the basis of the vapor pressure of pure water and NaCl solution. Options are: vapor pressure in container A is more than that in container B. Vapor pressure in container A is less than that in container B. Vapor pressure is equal in both the containers. Vapor pressure in container B is twice the vapor pressure in container A. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option A. And due to the presence of non-volatile solute NaCl in the beaker B, so we have given that in the beaker B we have a NaCl solution which is non-volatile. So due to the presence of non-volatile solute NaCl in the beaker B, the vapor pressure of the beaker B decreases and become less than that of A. Right? Because water is a volatile solute or volatile solvent. And on comparison, NaCl is a non-volatile. So the beaker B vapor pressure will decrease and become less than that of A. And hence, option A, as stated, is the correct answer. Okay, let's move to question number 14. A 0.001 molar solution of platinum ammonium whole 4 Cl whole 4 in water had a freezing point depression of 0.0054 degrees Celsius. If Kf for water is 1.80, the correct formulation of the above molecule is. So we have given a molecule, a complex compound here in the water, and it has a freezing point depression of this, and it has a molar value of 0.001, and the Kf for water is given as 1.80. So we have to find out the correct formula for this. So options are PTNH3 whole 4 Cl3 Cl, PTNH3 whole 4 Cl2 Cl2, PTNH3 whole 4 Cl Cl3, PTNH3 whole 4 Cl4. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer will be option B. So let's suppose that this is the complex we have given, right? Complex compound we have given in the question. On dissociation, let's suppose it is give n moles. Therefore, I will become n. I will become equal to n. But from the given data, we have del TF equals to IKF into molality. Del TF is given, which is 0.0054, and I is we have taken as N. KF is given 1.80, and molality is also given, that is 0.001. On solving these, we have N is equals to 3. So N will become 3. So the formula must be the one which gives 3 ions of products, because N is the number of moles which we get after the dissociation of this compound, right? So this compound should be dissociate in 3 number of ions. So the correct formula will be platinum NH3 whole 4 Cl2, and Cl2 is outside. So on dissociation, it will give 2 Cl negative plus this component of positive, right? Hence 3 ions will be produced. Hence the option B is the correct answer. Okay, let's move to the question number 15. Seawater is found to contain 5.85% NaCl and 9.5% MgCl2 by weight of solution. Calculates its normal boiling point assuming 70% ionization for NaCl and 50% ionization of MgCl2. The Kb for H2 is given as 0.51 Kelvin kg per mole. Options are 101.4 degrees Celsius, 102.29 degrees Celsius, 103.27 degrees Celsius, or 99.46 degrees Celsius. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option B. So 100 gram of solution contains 5.85 gram of NaCl given in the question, which will be equal to, on dividing its from its molar mass, it is equal to 0.1 mole of NaCl. Similarly, 100 gram of solution contains 9.50 gram of MgCl2, so it will be equal to 0.1 mole of MgCl2. Hence, the weight of solvent H2O will be the 100, which is the weight of solution, minus the weight of these two solute, is 5.85 plus 9.50. And the weight of solvent is coming out as 84.65 gram. So NaCl is given that it is ionizes 80%. So NaCl will give you Na positive plus Cl negative. So I will be equal to total number of moles 1 plus y minus 1 times x, which is equals to 1 plus x. X is the degree of ionization. So as NaCl ionizes 80%, so 1 plus 0.8, which is equal to 1.8. So I will be equal to 1.8. And in this equation, we have y is the number of ions per mole of solute. Hence, the number of moles of NaCl from 0.1 mole due to ionization, because we have just calculated the 0.1 mole of NaCl is present. So the NaCl from 0.1 mole due to ionization, the number of moles of NaCl will be 1.8 multiplied by 0.1, which is equals to 0.18 mole. And it is given that MgCl2 ionize 50%, so MgCl2 on dissociation give Mg2 positive plus 2Cl negative. I will be 1 plus y minus 1 times x, which is 1 plus 2x, and 1 plus 2 times 0.5, because it is ionizing 50%. So degree of ionization will be 0.5. So I will be equal to 2 for MgCl2. Now same thing, that the number of moles of MgCl2 from 0.1 mole will be equal to 2 into 0.1, which is 0.20. So total number of moles of NaCl and MgCl2 in a solution is coming out as 0.18 plus 0.20 will be equal to 0.38. And you can see that we can write N1 plus N2 times I is equals to 0.38, right? Because number of moles of both NaCl and MgCl2 into I will be equal to 0.38. So elevation in boiling point is given by this formula, which is 1000 multiplied by Kb multiplied by I and multiplied by the weight of, molality. Molality is weight of solute divided by weight of solvent in kg. So for kg, we have multiplied it by 1000. On putting the values in this equation, we have del Tb is equals to 2.29 degrees Celsius. And hence, the boiling point of solution will be 100 plus 2.29, which is 102.29 degrees Celsius. Okay. So our correct answer will be option B. Yeah. Okay. Thank you.